Proportion and problem solving with rational equations. So we're going to be solving some proportion problems. So to start out with, here's an example of the kind of equation that we have to solve when we solve one of those proportion problems. 2 over 5 equals x over 11. Now, I know of a couple of different ways that you could go about solving this. A couple different ways you could think of what's going on here. One way is to do it the way we talked about in the last section. When you have an equation that involves fractions, look at the denominators of those fractions and figure out what the lowest common denominator would be. What's the smallest thing that's divisible by both 5 and 11? Okay, how about we just multiply those together and get 55. So we can do 55 divided by 5. We can do 55 divided by 11. So what we're going to do with that is we're going to multiply both sides of the equation by 55. 55 times 2 over 5 equals 55 times x over 11. And the point of doing that is now we can do 55 over 5 is just 11, and this 55 over 11 would just be 5, and now there are no fractions left. It's just 11 times 2 equals 5 times x. Then, of course, 11 times 2 would be 22, so 22 equals 5x. And then to get from 5x to x, divide both sides by 5. Then x equals 22 divided by 5. Or if you did that on a calculator, it would give you the answer in decimal form as 4.2. Now, there's another way we could handle this. A sort of shortcut when you just have one fraction by itself on one side equal to another fraction by itself on the other side. Just one fraction equal to another fraction. Then we can sort of take a shortcut where we sort of cross multiply this numerator times the opposite denominator is equal to this numerator times the opposite denominator. So in this example, that means the 2 times the 11 is equal to the 5 times the x. Now notice that's the same thing we ended up with over here. So the reason this works is because we can multiply both sides of the equation by the common denominator, and then the denominators divide out, and that's what we get. But anytime you have this situation where it's just one fraction equals another, probably the quickest way to take care of that is just to multiply across like this. Now let's solve some actual problems involving proportions, involving one fractional or ratio expression equal to another. Chuck's van traveled 84 miles on 6.5 gallons of gasoline. At this rate, how many gallons would be needed to travel 126 miles? Okay, so the proportion here is between miles and gallons. Miles and gallons should be the same proportion no matter how many miles you travel. So I'm going to set this up as two fractions being equal to one another, and each fraction is going to have miles on top and gallons on the bottom. It doesn't matter which is which as long as we're consistent. But if we put miles on top and gallons on the bottom in one of the fractions, it has to be the same way in the other one. So it's really a good idea to actually write down how you're setting this up, what goes on top and what goes on the bottom. So 84 miles on 6.5 gallons. So one of these fractions has 84 for miles on top and 6.5 for gallons on the bottom. What about the other fraction? On top, we put the miles, and we have a number for that. That's 126. On the bottom, we put the gallons, and we don't have a number for that. That's what we're trying to find. So I'll call that X. So 84 over 6.5 equals 126 over x. We need to know how many gallons goes here so that 84 miles in 6.5 gallons is the same proportion as 126 miles to x gallons. So now we just have to solve this equation. We can multiply across. 84 times x equals 6.5 times 126. Then 6.5 times 126 is 819. So now we're looking at 84x equals 819. And to get just x, we got to divide both sides by 84. So 819 divided by 84 comes out to 9.75. So the answer is 9.75 gallons of gas. Okay, another proportion problem. This one has to do with similar triangles. Similar triangles are triangles that are the same shape, but not the same size. One is just an enlargement or a shrinking of the other one. But if they are similar, they have all the same angles, and then the sides are in the same proportions. So we can sort of match the sides up from one triangle to another if they're similar. So in these two triangles, the 9 matches with the x, the 6 matches with the 4, and the 12 matches with the 8. And so those are in the same proportions. 9 over x, and 6 over 4, and 12 over 8 are all equal. So to find the number that goes in for x, we can set this up as either 9 over x equals 6 over 4, or we could do 9 over x equals 12 over 8. Let's do the first one. 9 over x equals 6 over 4. How do we solve that? Well, multiplying across gives us 9 times 4 equals 6 times x. And then 9 times 4 would be 36, so 36 equals 6x. Then divide both sides by 6, and we get x equals 6. So that would be the answer. That's the number that goes here. Another example, if a computer can download a 10 megabyte file in 4 seconds, how long would it take to download an 85 megabyte file? So the proportion here is between megabytes, the size of the file, and seconds, the time it takes to download. So I set this up with megabytes on top and seconds on the bottom. You could do it the other way around, but it has to be the same for both sides. So we know that 10 megabytes goes with 4 seconds. So we can set that up. And then over here, the number that goes on top should be the number of megabytes. That's 85. And on the bottom, we should have the number of seconds. And that's what we're trying to find. How long? How many seconds? So we'll put an X there for that. And now we will solve for X. 10 times X equals 4 times 85. So 10x equals 340. So divide both sides by 10 and you get x equals 34. So the answer to the question, how long would it take, is it would take 34 seconds. Okay, in this video we've looked at proportion problems. There's another kind of problem in this section that leads us to solving equations that have fractions in it, and that is work problems involving like 2 people or 2 machines or 2 work crews working together on the same job. And we'll talk about that in the next video.